Alright, GPT-5 is here, and it's now the default for everyone, even free users. The change is immediate. You type a question, it responds, and you notice the difference right away. It's faster. Not just in technical tests, but in the way it feels when you use it. On light questions, it's about 30–50% quicker than the old model. You'll see it in the first few prompts. You'll feel it after a while. The delay you got used to? Mostly gone. But speed isn't the main story. The real story is simplicity. Before, the app made you choose between a mess of models and modes. Reasoning here, coding there, mini for this, pro for that. GPT-5 folds all of that into one brain that routes for you. Ask something shallow, it goes light. Ask something deep, it thinks longer on its own. No switches, no drop-downs, no second guessing. Just ask. That shift matters. It's not just a bigger model, it's a unification move. Under the hood, multiple capabilities get picked per task without you telling it what to do. And it shows up as less friction, less decision fatigue, fewer dead ends, more doing. Coding is where this hits hardest. The new model writes cleaner scaffolds, reasons through structure, and actually follows the constraints you set. It's quicker to get to something you can run, and more willing to revise itself when you point out a flaw. It still slips. It can still assert rules that don't exist. But when you push back, it's better at catching its own mistake and fixing it without spiraling. Less babysitting, more building. Is it perfect? No. Hallucinations didn't vanish. They're reduced, but not gone. Ask for a list that sounds plausible and it can still invent with confidence. The difference now is consistency. It's more likely to give you the right shape on the first pass and more likely to converge when you nudge it. Useful progress, not magic. Creativity is mixed. The writing voice has more edge, more analogies, more rhythm. It reads less like a spreadsheet and more like a script. But if you were hoping for a giant leap in image generation quality inside the same app, temper expectations. It's not the headline upgrade here. The win is control and coherence, not flashy art. The subscription math stays simple. The monthly plan doesn't change. Free users still get in with caps. Hit the limit and you don't get locked out. You drop to a lighter GPT-5 mini automatically and keep moving. That single detail turns "come back tomorrow" into "keep working now." It's a small thing that feels big. API folks get a gift too. Output tokens are priced at $10 per $1 million, which is aggressive next to rivals charging many times more for their top reasoning tiers. If you're shipping features or agents at scale, that gap isn't theory. It's your burn rate. And because GPT-5 reduces the need to hand route requests to a dozen narrowly tuned models, you also save on complexity. Fewer knobs, fewer brittle pipelines, fewer surprises at 2 a.m. Now, the hype. You've seen the posts. First to surpass humans on X. New one model. Depending on which chart you look at, GPT-5 is either the PhD in your pocket or just another strong contender. Some leaderboards light up. None of that changes what you actually feel in day-to-day use. You ask a quick question. It answers fast. You hand it a gnarlier task. It slows down on purpose, reasons, and gives you something sturdier. You point out an issue. It corrects with less drama. You move from idea to draft, from draft to code, from code to a running thing, without thinking about which model to pick for each step. That's the upgrade. There's a quieter win too, consistency across tasks. Old chat models could snap from "nailed it" to "what just happened" with no warning. GPT-5 narrows that gap. That doesn't make it a replacement for experts. It makes it a better teammate for them and for everyone else. If you're a developer, this is the first version that feels comfortable to lean on for end-to-end scaffolding. You still own the architecture. You still enforce the rules. But the model now gets more of the conventions right out of the gate, and it's faster to adjust when you ask for something different. It also resists collapsing into vague advice when the problem tightens. That's new. If you're a student or researcher, the speed plus routing combo means you can jump between summaries, outlines, and deeper dives without context loss. It won't always cite perfectly. It will still need verification. But it's less likely to derail and more likely to track the thread you set at the start. If you're a creator, The writing improvements are the part to try first. Users get a meaningful slice. Paid users get headroom without relearning the tool every month. And builders get a cost profile that makes shipping a lot less scary. This isn't artificial general intelligence. It's not the end of work. It's not the end of anything, really. It's the end of choosing a model before you can start. That alone makes a huge number of workflows feel lighter. Research, prototyping, docs, debugging, planning, you name it. The model fades into the background and the work comes forward, which is exactly how this was supposed to feel all along. So try it faster where it should be, slower where it has to be, smarter about when to switch gears without making you think about it. That's GPT-5 today. If you've tested it, drop what surprised you. If you're just getting access, start with something real you've been putting off. Then tell me if it helped you finally finish it. If you think this is crazy, wait until you hear this. Skild AI is on a mission to blur the lines between virtual intelligence and the real world. They are building AGI for robots. The goal is a single shared brain that can think, adapt, and act across many machines. Skild believes this leap could bring physical AGI much sooner than anyone expected. Picture one AGI brain, strong enough to guide any robot, from dog-like machines climbing stairs to humanoids handling delicate tasks. That's what Skild AI is promising, and what they've shown already is nothing short of groundbreaking. You might think this is just another update or that we're hyping it up, but it's not. Full AGI for robots, and it's truly transformative. Skild AI isn't just tweaking old ideas or copying rivals. They are building what they call an omni-bodied foundation model. It's a single AI brain that can live inside many kinds of robots, from warehouse arms to full humanoids, and handle jobs without fresh code every time. In July 2025, they showed a demo of robots of many shapes moving together, all powered by one brain. In that demo, quadrupeds marched over rough ground. Humanoids bent to pick up clutter. Wheeled bots worked alongside them. None of this needed separate programming. It showed the depth of Skild's omni-bodied brain. One robot brain handled everything, thinking, adapting, and responding whether it was a dog-like bot, a humanoid, or a wheeled machine. All of it came from one shared intelligence, a clear step toward true AGI in the real world. Hey guys, Alfie here. Before we go further, let me set the stage. Here's why this is groundbreaking. The problem with traditional AI is simple. It is stuck in the digital world, like a brain trapped in a screen. It's great at games, text, and images, but it fails when it has to touch, move, or manipulate anything in real life. These digital brains can chat, draw, and calculate. They can't even pick up a cup without breaking it. Skild AI is changing that. They are building a general-purpose robotic brain called the Skild brain. It is made to learn from real-world experience. They aren't chasing narrow skills, they are chasing AGI for robots. A universal brain that lets any type of robot think, adapt, and act with real physical awareness. Most AI models only work for one robot or one task. Skild's approach is different. It's a universal omni-bodied foundation model. The vision is bold and simple. One AI, any robot, any task. Here's why that's a big deal. Normally, robots need heavy programming made just for their hardware and their jobs. Want a robot dog to stay balanced? Or a robot arm to pick up something tricky? You would need a new, carefully built AI for each one. Skild flips that idea. Its omni-bodied brain trains on many robots and many tasks. This makes it flexible in ways old systems aren't. Balance learned on a four-legged robot can help a humanoid stand tall. Every robot gets smarter through shared experience. And they even train their AI on human movement, because Skild says humans are just another type of robot. The more diverse the data, the smarter the brain becomes. To really understand how one brain can work across so many different robots, you need to get this first. Traditional robot control is rigid, one program for one machine. Skild takes a different path because their goal is AGI for robots. This is where their hierarchical control architecture comes in. It builds directly on that idea. Skild needs a system that can think big and still handle small details. Think of it like this. There's a high-level decision maker, the strategic brain, that plans what to do, like moving to a spot or deciding how to grab an object. Then there's the low-level executor. It turns those plans into tiny motor moves and adjustments. This split lets the AI think in broad strokes but still control each robot's unique hardware with care. This big vision hits a major challenge. It's the same challenge every robotics team faces: data scarcity. Robots can't download billions of experiences from the internet like chatbots can. Every bit of robotic data is rare and hard to get. Skild solved this with a layered approach. Massive simulations let their AI run countless virtual trials fast, gaining huge experience. They add in tons of online videos of humans doing tasks, so the AI learns how we move, picking things up, climbing stairs, doing everyday stuff. But that's not enough. Real-world data is key. Skild runs tests in the real world and sends those lessons back into the brain. And here's the kicker. Once Skild's AI is in the field, every robot shares what it learns. That data flows back into the main brain. It's a loop of learning. Each robot helps the whole system get smarter. Each use makes the shared brain sharper. And the results are here now. They're not just cool demos. They look like proof of AGI in the making. In July 2025, Skild showed a teaser with many robots, all shapes and sizes, powered by the same Skild brain. Viewers saw robots climb slippery stairs. Humanoids stayed balanced after being pushed. Robots sorted cluttered objects without special code for each task. This wasn't flashy robot dancing or gimmicky backflips. These were hard, real-world jobs that show the heart of AGI for robots. They need real-time sight, physical reasoning, and quick thinking in messy, unpredictable places. Safety around humans is another breakthrough from Skild. Robots powered by their AI intuitively apply gentle force, adapting their behavior based on surrounding human presence and unpredictable disturbances. Imagine deploying these robots in warehouses, factories, or homes without worrying about human safety. It's adaptive, fault-tolerant behavior typically reserved for specialized robotic systems, now accessible through one general AI brain. And all this from just one AI, without custom programming for each scenario. Skild's robotic brain demonstrates emergent capabilities, skills arising naturally from massive-scale training rather than explicit coding. Early adopters are already impressed. Investors highlight unprecedented precision in tasks like stair climbing, attributing it to Skild's super brain that instantly upgrades any robot's intelligence. Backed by industry giants like SoftBank, Amazon, and Jeff Bezos himself, with investments soaring into the hundreds of millions, Skild isn't just making waves, they're starting a tsunami. Their recent $300 million Series A funding underscores industry belief in their vision of physically grounded AGI. A vision where robots don't just learn from simulated data, but embody common sense and adaptability through real-world experience. Looking ahead, the implications are staggering. Skild AI's approach promises a future where any robot in any environment can instantly tap into a shared intelligence, capable of handling complex, dynamic tasks with human-like agility. It's not just AI evolving, it's our entire interaction with the physical world being redefined. As Skild continues refining their model, demonstrating ever more complex behaviors, they're not just pushing robotics forward, they're reshaping our understanding of intelligence itself. The era of physically grounded AGI is not just a distant dream. It's here, it's real, and Skild AI is leading the charge. If you think that's crazy, wait until you hear this. Hexagon AB just stepped onto the robotics battlefield, and their newly unveiled humanoid robot Aeon is already making waves. Not just for its futuristic aesthetics, but because it's designed to fundamentally transform factory floors and construction sites. Imagine a robot that not only walks and moves like a human, but can actually think, adapt, and operate tirelessly around the clock. Welcome back, guys. Alfie here, and you're watching the AI Nexus, your ultimate destination for groundbreaking tech updates. We're diving headfirst into one of the boldest robotic unveilings we've seen this year, Hexagon's Aeon. Let's kick things off with the introduction that got the industry buzzing. Aeon was unveiled at Hexagon Live Global 2025, stunning audiences with a working prototype. It didn't just stand and wave, it demonstrated real-world practical capabilities. But how does Aeon really change the game for industrial robots? Stick around, because the answer will amaze you. Aeon isn't just another robot. It's a precision monster engineered specifically to handle error-prone repetitive tasks in manufacturing, logistics, and construction, areas facing severe skilled labor shortages globally. Aeon is designed to complement and safely coexist with human workers, bringing automation from isolated tasks into dynamic, real-world adaptability. It's not just about replacing humans, it's about extending their capabilities, blending machine consistency with human-like mobility. Think of Aeon as the ultimate teammate, one that never sleeps, never slows, and always performs. Hexagon's chairman, Ola Roland, highlighted how Hexagon's decades of expertise in precision measurement and sensor technology uniquely position it to excel in robotics. Aeon represents a bold move into the rapidly growing humanoid robotics space. But can it really outperform giants like Tesla and Figure AI? We'll explore that shortly. Let's get into the tech behind Aeon, where the magic truly happens. But first, a quick note on Hexagon itself. Based in Sweden, Hexagon AB is a global tech powerhouse specializing in industrial software and precision sensors. Their solutions power everything from aerospace and automotive systems to smart factories and geospatial mapping. In short, they know accuracy and scale like few others. Now back to Aeon. First up, agility. Aeon is impressively nimble thanks to advanced locomotion tech and high-performance actuators from Swiss motion experts at Maxon. It moves fluidly through complex factory environments, down narrow aisles, around tight corners, and across uneven floors, all while performing precise tasks with absolute accuracy. Unlike traditional robots, Aeon doesn't need specialized infrastructure. It moves effortlessly through spaces originally designed for humans. But agility alone doesn't set Aeon apart. There's something even more impressive. Aeon's true strength is its incredible spatial awareness. Aeon is powered by a suite of cutting-edge sensors. These include visual cameras, depth sensors, LiDAR, and tactile feedback systems. Together, they form a multimodal sensory setup. This allows Aeon to understand and analyze its surroundings in real time. The robot makes quick, informed decisions, safely navigating dynamic environments without colliding with obstacles or workers. It's the kind of awareness usually reserved for sci-fi movies, now very much a reality. And just when you think that's impressive, Aeon has another trick up its sleeve. Versatility is another factor that sets Aeon apart. Think of an F1 pit crew, but in humanoid form, changing its own power pack in seconds. Aeon's battery swapping mechanism allows continuous operation around the clock, crucial for industries that can't afford interruptions. Aeon is built to be a general-purpose worker. That means it's not limited to just one job or one environment. It can do many types of work, like helping with machines, moving materials around, or checking parts for quality. Aeon can even scan its surroundings to create a full 3D model, something known as a digital twin. This makes it useful in all kinds of places, from factories to construction sites, without needing to change how those places are built or run. But just how detailed can Aeon's inspections be? You'll want to keep watching for this. Imagine Aeon meticulously inspecting aircraft parts or operating CNC machines with the precision typically found in specialized automation systems. Its ability to quickly swap batteries ensures non-stop productivity, but Aeon's capabilities don't stop there. Let's talk about Aeon's brain. Aeon has some serious brain power behind it. It runs on NVIDIA's latest robotics platform, thanks to a close partnership between the two companies. At its core, Aeon uses NVIDIA's Jetson Orin modules. These help the robot see, understand, and react to its environment in real time. And yes, there are already plans to upgrade this system for even more power and control. But hardware is just part of the story. Aeon's AI went through intense training using NVIDIA's Omniverse and Isaac simulation platforms. Think of these as virtual training camps where the robot could practice moving, reacting, and completing tasks. It learned everything in a safe, controlled digital space before stepping into the real world. That's what makes Aeon smarter, faster, and more ready for action from day one. It learned complex movements and tasks rapidly, significantly accelerating deployment timelines. But how does Aeon keep getting smarter over time? It's all about how it connects with the cloud and edge systems thanks to a partnership with Microsoft Azure. Every time Aeon performs a task, it collects data from its sensors. That data is then sent to the cloud, where it gets used in training simulations. These simulations help improve Aeon's performance by letting it learn from its own experiences, almost like practice in a virtual world. This loop of learning and updating never stops. Every time Aeon completes a task, it learns from the results. That new knowledge gets added to its system automatically. This process is called a digital flywheel. It means the robot keeps improving over time without anyone having to manually update it. It's like the robot is practicing and getting better on its own. When you mix this smart software with strong, reliable hardware, you get something special. That's what makes Aeon a truly next-level adaptive robot. The real-world implications of Aeon are massive. Hexagon has already secured pilot programs with heavyweight industrial players like Schaeffler and Pilatus Aircraft. These companies are testing Aeon in live environments. Schaeffler's advanced production tech lead, Sebastian Jonas, highlighted Aeon's disruptive potential, noting that humanoid robots like Aeon could soon become essential fixtures in advanced manufacturing. Pilatus VP Roman Amenager echoed this sentiment, seeing Aeon as crucial for automating challenging tasks. But will Aeon truly live up to this promise in high-cost regions? The upcoming months will reveal all. Aeon signals a transformative shift toward humanoid robots becoming a practical, flexible workforce solution, rather than merely tech demonstrations. Its capabilities in reality capture, machine tending, logistics, and quality assurance could drastically reshape industries struggling with labor shortages and operational inefficiencies. Yet critical questions remain. Can Aeon withstand real-world industrial rigors day after day? How will human workers truly feel about collaborating with advanced robotic colleagues? And most importantly, does Aeon provide measurable ROI for businesses adopting it? Pilot programs with Schaeffler and Pilatus Aircraft will answer these questions, shaping Hexagon's broader commercialization strategy. If successful, Aeon won't just be another robot. It'll become a blueprint for next-generation industrial automation. Hexagon's timeline for Aeon is aggressive, yet achievable. Following successful pilot trials, broader deployment across multiple industries is anticipated by late 2025. But what will Aeon's true impact be? We'll have to wait and see. In short, Hexagon's Aeon isn't just an impressive humanoid robot. It's a glimpse into the future of automation, blending human-like dexterity, advanced sensory perception, and cutting-edge AI. With Aeon, Hexagon isn't just joining the robotics race, they're aiming to redefine it.